All right, this will be the last video for the WA2 revision paper. And we will continue from where we left off just now. And we are now at question number 4. So for question number 4, you are given two things here. You're given number 1, this compound, carbon dioxide, and number 2, ammonia. So in this question, you will have to show the electronic structure of the two molecules by using dot and cross diagrams. I think you have done this before in class. So look through the various pages of the textbook, and you will realize that carbon dioxide is shown in this particular manner over here, whereby you have your shells that are shown there. And remember, as a way to check, okay, because in this question, your carbon dioxide is made of two nonmetals. Therefore, there will be the sharing of electrons that are being drawn in the dot and cross diagram. And for ammonia, which is the second compound, okay, for ammonia, it is another it's another compound that is formed between two nonmetals. Therefore, you will again have the your sharing of electrons that will be featured. Again, bear in mind that you should always ensure that altogether you have 2 or 8 valence electrons in the shells that are drawn. So whether it is CO2 or ammonia, okay, make sure that you have the two elements. You have got 8 electrons over the elements featured. Okay, of course, the exception is hydrogen, because the maximum number of electrons that hydrogen can have will be 2. So with that, that's for dot and cross diagram of your two compounds there. And then in part B, they ask you to explain, okay, why these molecules have low melting and boiling points. And the reason is very standard once again. Okay, again, because the question talks about in terms of structure and bonding. So refer to the structure. Okay, the first thing is to identify that your molecules have the simple molecular structure, and then explain the reason why the molecules have low melting and boiling points. So in such kinds of questions, typically it is 2 marks. So first mark is awarded when you have stated the correct kind of structure. And then the second mark is given when you explain that there are weak intermolecular forces of attraction and that it requires very little energy to overcome. So overall, okay, this whole portion of your answer will be awarded the second mark. So this is a very standard kind of a question that you will encounter. Now in question 5, you have got 2 elements here, P and Q, and together they form this compound of a formula PQ2. You are told that elements P and Q have electronic configurations shown respectively, and take note of the number of valence electrons, because this tells you that P is a metal, whereas Q is a non-metal based on the number of valence electrons. So this is something that you have to recognize, and you have to be very familiar with the electronic configuration as well as the way to identify if they are metals or non-metals. So with that, draw a dot and cross diagram to show your arrangement. And because this is a reaction between, or rather this is a compound formed between a metal and a non-metal, the kind of bonding that you should show will be that of the ionic bonding. So now I'm going to show you the diagram with the square brackets, and it will look like this. Okay, where you have 1 p ion and 2 q ions. So your diagram, make sure that you have the dots as well as the crosses that are featured. You also have shown your square brackets and the charges of the various particles. And part B is an explanation question. Again, you are supposed to explain why it has a high melting point as well as a boiling point. So talk about the structure first. 1 mark for the structure that is correctly written, and second mark will be when you talk about the presence of the strong electrostatic forces of attraction, and that this requires a lot of energy to overcome. So again, it's very standard, and take some effort to remember them, and you will not go wrong. Okay. Now for part C, okay, what is the other physical property of PQ2 other than it having a high melting and boiling point? So because this is an ionic compound, so altogether we have learned 4 properties. So 3 are featured here. Okay, of course, the first one is high melting point, boiling point. This is another property that you can write down, soluble in water. The third property will be to talk about it being able to conduct electricity in the specific states. There is one more. You can say that it is hard but brittle. Okay, this is also given in your textbook. And yeah, this sums up the 4 properties, okay, including it having a high melting and boiling point. And in part D, now you have another element R with the configuration of 2,6. Now this again will be a non-metal because it has 6 valence electrons. So R 2, 6 and Q is 2, 7. Sorry, 2, 8, 7. So between these 2 non-metals, the kind of bonding should be a covalent bond. And the chemical formula, you can look at it, R with a total of 6 valence electrons, okay, means that it will have a valency of 2. It can form 2 more bonds. Q with 7 valence electrons, okay, means that it has a valency of 1 because it needs 1 more electron to form that octet configuration. So with that, you realize that you need altogether 2 of the Q particles. Oops, let me just. Okay, you need 2 Q to have to be able to form a balanced compound, and therefore the formula you realize now is either you can write it as RQ2, or another acceptable answer here, because both are not metals, is Q2R. So this is the answer for part D. And finally, for question number 6, right, to balance the equations by writing numbers where necessary, again, I would like to emphasize, where necessary means that you don't have to write. If you're supposed to, if the number there is supposed to be 1, it means that you don't have to write any number. Okay, so in this case, balance fluorine first. There's 2 on the left, there's 1 on the right. So put a 2 in front of NaF. And now there's 2 NaF on the, sorry, there's now 2 sodium and 2 Na on the right, but only 1 on the left. So therefore put the 2 on the left. This balances the first part very, very well. The second part, where you have N2H2 as well as NH3, balance, you can first try to balance nitrogen. Nitrogen, there's 2 on the left, 1 on the right. So you put a 2 in front of NH3. Now there's 6 H on the right, but only 2 on the left. So you put 3 in front of H2. And this balances part B very easily. Okay, so I hope that these 3 videos altogether has helped you as you practice through this paper here. And yeah, if you like what you see, you can subscribe, you can like the videos, and I will see you in class very soon. All right, all the best for your WA2 on Tuesday.